Okay, hello. Hi. Hi. Okay, awesome. I need to make sure you guys are like alive so that I can speak, because it's weird to talk to dead people. All right, so it's cool to see lots of people here. Let's do survey time. How many of you people are JavaScript developers today? Okay, we'll do the inverse. How many of you aren't? Okay, all right, cool. So how many of you are Python? Java? Okay, PHP? Cool, all right. Ruby? Haskell? Lisp? Scheme? Scala? Okay, good. All right, great, we have a mixed crowd. All right, so my name is Pamela Fox, and about 4 months ago I started working for Coursera, which is a platform for university education. Has anybody here taken a Coursera class? Has anybody earned, got a score in a class? Oh, very nice. Okay, cool. I have, I think, 30% and 20% so far in my classes. All right, so yeah, I work for Coursera, and I started working 4 months ago. And when I joined Coursera, I had no idea what sort of stack Coursera was on. I was just like, it's cool. I don't care what your stack is. I'll make it work, and it should be fun. And I was just interested in just joining them on doing whatever they were doing. And then when I joined Coursera, and in the first week, I discovered that we actually had kind of 3 different stacks and 3 different architectures for our sites. And it's been really interesting in the last 4 months working with all these different architectures for the websites and seeing the different ways that they work and don't work. So today I want to talk about the different kind of stacks that we have at Coursera and just in the web today. And specifically, like the most modern stack and why I really like it and why I think you guys should all do it. And I'll give you a hint that the modern web stack involves a whole lot of JavaScript. So if you like JavaScript, it's good for you. All right, so first we go a little history, right? So our Web 1.0 stack was pretty basic because when the web first started, all we had was, HTML. So we'd have these servers that would output HTML, and when the user did something on the server, then it would do the request to the server would go and think, and then output a whole new HTML page, right? And that means the user actually has to wait every time they do some interaction. And we actually do have this kind of stack on Coursera. So this is our forums, or my test forums. And if I go and post here and do an awesome post and then reply, you can see it goes, it reloads the whole page. And so this is a very traditional stack. This is our backend that's written in PHP and with no particular framework, just PHP. And it's making calls to SQL to get all the forum stuff and then rendering out that page, and you'll actually see some SQL queries in it. It's not really my favorite stack to work in, first because it's PHP, but also because it's this very old style model. And it's not as great as the user experience because there's a lot of page loads, especially with a forum experience. A forum experience is one where you don't have to wait for entire reloads every time you do something. But we have that stack, so we deal with it. And that's what happens. So Coursera, it was co-founded by 2 Stanford professors, and what the history of it is that one of the Stanford professors kind of wanted to experiment with putting their class online. So that was the machine learning class from Andrew. And so he just got some of his Stanford machine learning grad students to put together the website for him. So they put together the website together in the quickest way they could, just hobbling stuff together. And that's that code that I was just showing there, that site. And we're still running off that today. So that's what happens in a startup is that you make that prototype and you're like, oh, we're totally going to make this better later. But it doesn't always happen. All right, so then we have what everybody affectionately calls Web 2.0, right? And this was really the rise of Ajax, with Gmail and Google Maps and all that, right? So the server outputs the HTML, and the HTML has quite a lot in it. But then when the user does something like presses this submit button or clicks a tab, we go out to the server, we request some data, we get back JSON, and then we use it just to populate part of the page, right? And we use this in some places on Coursera too, right? So this is an admin interfaces for making quizzes. This is like the machine learning one, right? So I might go edit some stuff, and then I save, and you can see it very quickly did a save there. So then I can keep editing and not have to reload the page. So that's a nicer user experience, right? And that's why Web 2.0 became such a big thing, because it was like, you know, a better user experience for the user. They didn't have to keep leaving pages to do what they wanted to do. But then we have the next stack, and we don't really have a number for it. And if I used Web 3.0, it would probably mean a bunch of other things too. So Web 2.5, and here we actually have a server outputting empty HTML, right? So the server simply outputs a web page that has basically an HTML tag in it and not much else, maybe a few script tags, but no actual real content. And then use JavaScript to build up that entire page. And then, of course, when the user does any interactions in the page, we're using that Web 2.0 style of going to the server, getting JavaScript, replacing that part of the page. But here you see in this architecture, we're doing pretty much like everything in JavaScript, right? We're just using the server as a way of serving like static content for that HTML, and also as a way of getting our data back. But all of our HTML and our logic and all of our presentation is done by JavaScript. And this is actually what we use for our more modern parts of Coursera. So this is www.coursera.org. And let me actually get out of presentation mode so I can prove to you that this is what it is. So if you view source on Coursera, you'll see the HTML tag, you'll see a bunch of meta tags, a script tag, but there's no actual, like inside the body, the only thing in the body is a loading div. That's the only actual HTML that our server puts in there. So the loading div and then these script tags, and these script tags are loading in JavaScript. So in fact, that means if I go into my Chrome DevTools and disable JavaScript, oh good, okay, and then reload, that's all I'm going to see. Because without JavaScript, there's no web page to look at. So the JavaScript is building up everything. And when I first found this out, like in my first week at Coursera, I was like, oh my God, you guys are insane. Like that is using JavaScript for a lot, right? But that's the thing is that these days, I mean, people don't really disable JavaScript that much anymore, right? I remember there was a time when we'd avoid using JavaScript because everyone disabled it. But if people disabled JavaScript these days, like they would have a subpar experience on so many sites that it's just not that common of a thing to do. So you rarely realize that a site is so dependent on something like JavaScript. So then I can go and put it back on and reload, and everything gets built up again. So all of that is built up by JavaScript that's in there. Okay, so that's the architecture that I want to talk about because it's interesting because I always, I was used to this architecture, which was cool. But this architecture, as it turns out, is also really, really cool. But I think it's also a little scarier because of how much we're doing in JavaScript. But I want to talk about why it's awesome. Okay, so as my example, instead of using Coursera.org, I want to look at the example of the admin interface because it's a little more interesting because we do more data saving and retrieving. So for Coursera.org, I have this admin I built so that we can have all of our university partners enter all their information about all the really cool courses, upload logos, all of that stuff, right? And it has the same architecture as www.coursera.org. So the first step in this process is that we have a server that serves that very basic HTML. For us, we happen to use AWS. We use CloudFront for serving our static assets, which is also an AWS service. And we have an Nginx server also. But in the case of this HTML file, it's actually just static. So we just have an Nginx returning it here. So the next step is for the JavaScript that's inside that HTML to go out and build up that interface. And there's lots of ways you could do this, but the particular stack we use something called require.js with Backbone, and then we use Jade for our templates. We also use Stylus for our CSS. So just brief hands, how many people have used require? Nice. Backbone? Jade? It's not as cool. Cool, so let's just dive into that. So require, for those of you guys who haven't used require, it's pretty cool. It's a way of, it makes it easy to manage your JavaScript dependencies, right? So instead of having to remember in each HTML file which JavaScript libraries you need to pull into that because this part relies on this and this part relies on this, instead you can just define your modules. So it encourages you to write modular JavaScript, right? So you define your modules, and in your module, at the top, you'll say what other modules or libraries that depends on. And so then require will actually take care of appending the script tags for you based on what you've said you require. And the other cool thing is that when you're actually going to, so when you're debugging locally, it's fine to bring in all those JavaScript files separately. But sometimes you could have like 30 or 40 JavaScript files, and you definitely don't want to do that once you're actually in production because that's all those HTTP requests. So what we do is for production, we run this script, we run r.js, which looks at our required dependencies and optimizes the home module so that we bring in and concatenate all the different JavaScript that's required to make our home page show up and look good. And then if a user goes to a page and there's a module that's required by that page and it's not there yet for whatever reason, then require will take care of loading it in, right? So it's really nice for managing your dependencies. So this is in our homepage. Our homepage is basically including require, including this require function that then will load in this routes file. And the routes file is a Backbone routes file. And in that file, we define all the different URLs on our site, and we map each of the URLs to the views, right? So we say, okay, when you go to the home page, you should be loading in this view. When you go to the profile page, you should be loading in the profile view. So that means we just have all of the different parts of our site defined in that one page. Now, that's typically you'd have that on the server, right? Like if you had your Django app or whatever, you would define all your URLs and your views, and you would map them all on the server. But we're actually just mapping them all in the client. So an example of the router is just a snippet. So for the routes, you usually define a dictionary of routes. And so you'll have this is the actual, what the URL will look like. And you could have variables in there, just like you do in a server-side framework. And then inside that route, that's a function that will get executed if the URL matches that route. And it'll load in a view and maybe also load in some related data collections. And this is a Backbone view. So for those of you who haven't used Backbone, Backbone view is basically a way of encapsulating all your presentation-related logic. And usually a view has a DOM element associated with it, and it returns a DOM element to any other views that actually nest that view. So you can actually do nice nested views. And it typically has an initialize function and a render function, right? Initialize is called when you construct the view, if you want to initialize any variables. And render is called when that view is actually rendered and appended into a page, right? So typically what you do in the render function is that you'll actually go and call your template, whatever templating library you use, pass in some variables, and render that into an element. So for us, we happen to use Jade templates, but you could use handlebars or mustache or whatever your favorite template language was, right? Or just no templates at all. But that builds up a DOM. But we still don't have data, right? So that just showed, building up some HTML. But we want data, right? And data we need to get from our server. So that's the next step. So here we want to go from the JavaScript. We want to ask the server for some data, get it back as JSON, and then use it to continue building up our page, right? So typically what we do on Coursera is that we'll build up the skeleton of the page, which doesn't have any of the data in there yet, but it still is something for the user to look at, right? You always want to give the user something to look at. So we'll build up that skeleton, and then we'll go out, fetch the actual data, and fill in the different parts of it, right? So here we're using Backbone to call out to Django app. And basically, we're doing this in a very RESTful way, and that's really what Backbone encourages, and it's just a good way of doing stuff on the internet, right, since the web was supposed to be RESTful. But basically, for all of our data, we're using HTTP verbs to get it. If we're reading the data, we're using put or post if we're going to edit or create new data, and we just have URLs that identify all of the different data that we deal with. And Backbone encourages this by through its models classes. So Backbone has this Backbone model, and on the model you can define defaults if you want default stuff for your models. But the really important thing is if you want to use it with your server is to define a URL. So here I have admin/courses, and so Backbone now knows that whenever you use this model, that it's associated with that URL on your server. So it knows where to get the information about the model and where to put the information. You can also have collections of models, because very commonly you'll have multiple of something, and it's the same thing with the collections. It has a URL, it also has an associated model, and maybe you have other stuff like comparators to keep it sorted. All right, so then when you actually want to go and have your Backbone app communicate with the server, you use these collections and models. So in this example, I might construct a new courses collection, and remember that that had an associated URL with it. And then I assign an event handler. So I say, OK, I want to know when this collection is reset. And when that happens, we're going to call this function display collection. So it's really important to bind events to it, because you normally have something you want to actually do when the data comes back. And since it's asynchronous, you need a way of being notified once that data has come back or once it's changed. And then finally, we fetch that collection. So when we fetch a collection, it's just going to do an HTTP GET to whatever URL it found for that collection. And then our server is just going to return back with a JSON. And that JSON will look like an array of objects with the attributes and values. And then Backbone will read that into the collection, setting all the attributes. But it's a very clean API, as you see. And then maybe we have this function display collection that gets called once that collection comes back, and we might iterate through all the models in the collection and append them to the page, maybe rendering a template with them as well. But that's basically reading data. We also have a really nice way of saving data. So in this example, we create a new course admin model, and that also had that URL associated with it. We give it some information, right? And typically, we'd actually be getting this information from user input in a form. We would bind an event again. This time it's a change event. And then we save the model. And when we call save, that's what tells Backbone behind the scenes to go and do an AJAX request to send that JSON data, to serialize it, send it to the server using that URL. So this will end up doing an HTTP post to the URL, send that JSON, and then once it comes back, it'll have an ID from the server, and I could go and render that out again. So that's basically the way that our apps use Backbone to communicate RESTfully with our server. And it ends up being actually pretty clean and consistent across the site. So as you saw, when I disabled JavaScript, we saw nothing at all on the page. And some of you might think, like, well, that's bad because there are some things out there that don't understand JavaScript-built sites. One example is bots, right? The Google bot, it's just looking at your static HTML. I mean, it's getting smarter every day. Like the Google bot is probably smarter than most browsers these days. But generally it does better with non-JavaScript. There's also like the Facebook bot, and this is actually really important. Like if you have a public site and you want people to actually share stuff about it, like we've spent a while on optimizing what it looks like when somebody types in that URL in Facebook, and then Facebook goes and actually greps that URL, tries to find the information. And so this is actually really important because you want people to have a nice, pretty share in their Facebook feed. And it's the same thing with like Google Plus sharing and stuff like that, right? So these bots need something else to look at because they're not going to understand JavaScript. So luckily, we put some thought into that. So what we have is something we call a just-in-time renderer. And we run the just-in-time renderer every time we do a deploy, right? So every time we have new assets, new JavaScript, new everything, our deploy script actually takes care and makes sure that this just-in-time renderer gets called. And we implement this as it's a separate service. We might open source it one day, hopefully. It's written in Scala with the Play framework, and it calls the Java Selenium server. And if you guys haven't used Selenium, that's a way of automating browser interaction. So it can automatically open a browser. It can do clicks and stuff like that. So we use Selenium to control a Chrome that's running in an X virtual frame buffer. And then we just get that rendered HTML, and we'll just save it, and we serve it from another URL. And in our Nginx configuration, we just send the bots to that other URL instead. So they'll end up seeing the pre-rendered HTML, right? That means that there's no user-specific data in that pre-rendered HTML, but that's good, right? A bot shouldn't be looking at any user-specific view of something. They should just be seeing stuff that depends on the data. It does mean that maybe it can get out of date, like if we add new data. So it could be slightly out of date compared to what a user would see, but then we could just run it more often, right? We could run it on a cron or something like that. We usually deploy every day or so. It's pretty up to date. You might also think, what about testing, right? Like when we have all of this stuff in the client, how do we actually test this? I'll be honest, we don't test that much yet, but we're working on it. We're actually having our first ever testathon next week. It's internal, so you guys can't come. But we plan to spend like a good 3 days writing all sorts of tests for our stuff. But basically, we have a setup for it. And we have the two kinds of tests, right? Because we have both that Django API in the back, and we have all the JavaScript in the front. So for the back, we're just doing standard Python unit tests using the Django client, checking to see that we're getting back the attributes that we expect from the JSON, also checking on permissions, making sure we get back 403s when we expect it, because permissions is really, really important since it's an admin interface, so I have entire separate tests for that. And then in the front end, there's a lot of different ways that you can do front end tests, and there's a couple of talks today about testing. There's one coming up soon. And you can do unit tests, you can do BDD style tests. What we're going for is just doing Selenium tests, right? So the Selenium tests, we can actually remotely control the browser and say, okay, open this. So in this example, we open a window, we do this login, we wait for something to happen. So in Selenium tests, you do end up having a lot of waiting because this is Ajax-based, so not everything is available immediately. So if you click something, you might have to wait for something else in order to continue on with the test because you're waiting for the server to come back. But it works. And the nice thing about Selenium tests is that you're testing, it's an integration test, so you're testing the whole stack, right? So if something works via Selenium, then it works, right? And that's like it'll work for the user. And that's the really important thing to us because if it doesn't work for the user, then we get all sorts of really fun phone calls. So that's our testing strategy. So why do I really like this architecture? Besides the fact that I like JavaScript, I think it's cool. There's actually a lot of really good things about this architecture. So first, we have a separation of presentation and data, right? All of our presentation is in the JavaScript, and the backend is only taking care of data and security. And I find this really nice to have all of the presentation in the JavaScript because it means theoretically we can have a really clean break between our front-end developers and our back-end engineers. And we know if I'm looking to figure out what to change about a front-end, I don't have to look in two places, right? I don't have to look in both the server-side template and the JavaScript that decorates it. Everything is inside. Like all of that presentation logic is in a backbone view, and the HTML is all in those Jade templates. So there's just one place to look. So it's a very clean separation that I quite like. And having this separation also means other things. So first, it means it's easy to do multiple front ends, right? So I showed one interface for the admin, but sometimes I decide like, I don't quite like this list view or this form view, and I do a checklist instead. And it's really, really easy to present multiple front ends to the same data, especially with using Backbone, because there I even reuse the same models, and I just make new views, right? So it's very easy to whip up a new view for something, and that's good because then we can keep agile, right? We don't have to stick with this one UI because it's so hard to break from it. If a professor says it's too hard to use this, it's like, okay, fine, cool, let's do a new view, right? It's really not that much work, and we don't have to worry about retesting like our API and the data and the security and all that, right? We're just changing the view. It also means theoretically not just multiple JavaScript frontends, but multiple clients, right? So we don't yet have a mobile app, but at the point if we decide to do a mobile app, it'll be easier for us to do one because we already have the API layer, right? So all we have to do then is just build on top of that API layer in the client, the native SDK of our choice. So that's really nice as well. And it also means backend independence. So right now we're Django MySQL and we're also PHP MySQL, but we're talking all the time about what our next stack is going to be. And like I hear people talking about Go, about Scala, about Play. And for all I know, next week the backend team might decide that we're going to move to Cassandra and Play, right? Which is a whole different backend stack, right? But I'm not going to freak out because I don't have to rewrite the whole front end, right? Yes, I do have to rewrite the API, but I can just run my API test against it and be like, okay, cool, right? We managed to rewrite the API. And I actually think it's much easier to rewrite an API than a front end, right? So this is really important for us because we do want to be able to swap out our backends if we decide there's a backend that's better, especially since we're growing and it's hard to know exactly how big we'll grow and in what way. So we have to have that flexibility. And I'm pretty sure that we're going to have JavaScript for a while now, so it's safer to put as much into JavaScript as I can. And finally, it also means that if we decide one day that we want to have an external API for people other than us to use, it's really, really easy for us to do it. I mean, basically, we have an external API right now. It's just not documented. So if we decide one day to actually document it and make it real, we don't have to rewrite it and figure out how, what are we going to expose, right? We can just look at our existing APIs and decide, okay, cool, these are good, or maybe these need more security or something like that, right? So it makes it really easiest for us to go to that. And I think providing an API is actually a really important thing that companies today need to do so that users can mix and match their websites and extend them more. Okay, so to wrap it up, I actually have a wrap. I thought that there was kind of a nice rhyme in the talk title, so I started up an Etherpad with just the talk title, and then other people made it into a really, really long, epic rap about JavaScript. So I highly recommend that you check it out. I will just attempt the first 3 verses. I'm not a professional rapper. I know I look like one. But I'm just going to try this out. And I know this is like an enterprise conference, but you guys, yeah, it should be good, right? All right, ready? Okay, give me the mic, Crockford and Ike. From Netscape to Node, it's been quite a hike. On-click to require was quite a ride. With GitHub, my skills have got nowhere to hide. My lack of globals is a point of pride. I'm hitting my stride on the client side. JS in the front, REST in the back. Ain't it time you changed your stack? Server-side rendering, that's just a whack. Once you go back one, you never go back. Word. Yeah, you guys should check it out. It's awesome. All right, I'm over. All right.